Hi everyone, my name's Rebecca. I'm an ichthyologist but also a PhD student studying, specialising in loricariidae and looking at their evolution and morphology. So this video is really relevant and it's a topic I'm really interested in because I actually did a master's project involving looking at these diets of these fishes and actually looking at what is available in the papers and also looking at morphology and how their morphology differs even within the same genera, because I did do a master's project exclusively on the genus Cichlids, which you'll probably know as bristlenoses. But when we look at fish diets, it really doesn't reflect what these fish eat in the wild. And there's a particular study, but this study shouldn't be the only one to change how we feed our fishes, what we feed our fishes on, because there's been plenty of studies before that. And maybe this study does focus on carnivores, but we can apply it to herbivores as well, because if we look at animals in general, they are evolved and specialised for the diet they eat. Particularly you're looking at morphology maybe, and the jaws, so there's multiple aspects to jaws, not just the bit that you can see. There might be fangle jaws at the back of the mouth, so that's particularly important in cichlids. There's also another bone, I think it's the I can spell the name but I can't pronounce it, and that's very important in how these fishes feed. You might be also for like pacu, you could say also for cichlids, loricariidae, those lips might have some importance to how these fish are feeding. But then there's other aspects which will affect how well a fish can feed and how much it's getting from its food. And this is maybe less easy to identify. So this might be intestinal length, the morphology of the gut itself, and then the actual sort of biochemistry, I guess, of the gut, which would be like the enzymes. Enzymes are very specific to what they break down. So this does mean that if they're not evolved to eat that diet, they might really struggle to get their essential nutrients from that diet. And it might cause issues, say, as in you see with lactose intolerant people where they do not have the enzyme lactase. It causes, when they eat lactose, it causes issues such as, I think it's like fluid retention or fluid travelling out of the body into the gut, causing really major issues. Other than that, we've actually got the more biotic aspect of the gut, which is highly adapted to what fishes eat in the wild. And these things can take hundreds of years to adapt, and captivity won't really change, especially the morphology. You don't see discus evolving for any carnivorous morphological traits anyway. But also loricariidae, not that they're always fed a carnivorous diet, but also the biotic bit, you've got bacteria, archaea. Archaea are sort of a microorganism that's more closely related to animals, but they're also found within the gut, and these are very specific to what they're breaking down, and the species of these will vary depending on what this fish is feeding on. And obviously with captivity, certain breeding methods, they might lose this, they might change in these populations, and this is just something different to think about when it comes to diets. But what this study said, really, it was the first study that really was easy to see, but it's particularly focusing on carnivores, and it particularly mentions that the carnivorous species featured, which is a species of killifish, it's an insectivore. It doesn't actually digest omnivorous diets particularly well. So it resulted in slower growth, lower fecundity and unnatural liver size. Now if we apply that to other carnivores, they're probably seeing the same thing because they're not actually evolved to eat this particular diet. And you can say the same for herbivores. The problem is most diets are omnivorous in the trade, and I can bring up loads of different diets, but I've got a few here. I'm not going to show the brands, but if you look at the ingredients, they don't fit any particular fish. So this one is fish and fish derivatives, so that's the same as fish meal. Derivatives of vegetable origin, that's just vegetables and vegetable derivatives. Algae, oils, fats, mollusks, crustaceans, that doesn't fit into a herbivore, a carnivore, or anything that might be more niche, because further on I'll talk about the actual importance of really catering for those fish's diets. And then here I've got another one, which is fish meal, wheat germ meal, soya bean meal, wheat flour, loads of cereals here. I'll probably show pictures of the things, sorry. Whole crushed silkworm pupae, dried seaweed meal, and it's really difficult to tell which ones are actually catered for carnivores, omnivores, herbivores with the diet, with the ingredients. Here's another. This one is from what I remember, because it's basically fish derivatives, vegetable derivatives. And you're seeing a lot of, when you look at, these are totally different brands. I've chosen 3 different brands here, but I've got a selection of 6. And you're seeing a lot of the same ingredients, but some of these diets, people are like, oh, these are amazing quality, get these. But if you look at the ingredients, here's another. Fish and fish derivatives, vegetable protein extracts, cereals, oils and fats. There's more to a diet than looking at these percentages. Here's another. This one is particularly well recommended for being high quality, as people say. Fish and fish derivatives. So the one I just read, which that was really obvious because the packaging, is meant to be really low quality. It is out of date, I'll give it that. But that's meant to be low quality. But compared to this, fish and fish derivatives, cereals, crustacean, derivatives of vegetable origin. Obviously there's a few more, I'm not going to list the whole lot. Another one, vegetable protein extracts, cereals, yeast, algae, 14% spirulina, that's not entirely bad. Fish and fish derivatives. It makes it really difficult to understand what you're actually targeting these fish for, these diets, and none of these actually contain what the fish would eat in the wild. If we're looking at algivores, and that's kind of what I specialise in, I have discus, they are detritivores, that's very similar I think. I have platies, platies I think are insectivores, so exclude them, and the Corydoras. Balancistrus algivores, Ancistrus ranunculus, algivores, Balancistrus xanthellus, algivores. That's the diet I can recognise the best and give the best advice on. But some of these are recommended for algivores and contain very little to no algae. So if I was to feed most loricariidae, which are either detritivores or algivores, this diet which is aimed at them, fish and fish derivatives, these fish will probably never eat fish in the wild. So that's the highest part. Vegetables. Vegetables are not algae. Very different composition. Algae is very high in protein, minerals, vitamins. They have very unique vitamins and minerals that won't be found in other plants, because algae aren't always plants. I shouldn't have said that really, because some algae are bacteria, some are totally different in the tree of protozoa, some are closely related to plants. These fish, some will eat some plants, but they're not, the freshwater aquatic world isn't as well planted as people think. The detritivores might eat a bit more, but how much are they digesting if it's mentioned in their diet? Because generally you want to look at isotopic analysis. Most studies look at gut. So the gut, you kind of take with a pinch of salt of what they're actually digesting. So sand is found in a lot of the guts. Whether it has a function is difficult to say. But are they digesting sand? Probably not. Wood, found in many of their guts, they are not digesting wood. There has been isotopic analysis on that, and digesting sand. Blimey, their guts would have to be amazing if they did that. So it makes you think when you actually look at ingredients. And also remember that algae, so for algivores, detritivores, discus eat a lot of algae, even though I say they're detritivores. Algae can be, well, is really high in proteins and amino acids, so it can boost that value up, and people are like, don't feed high protein. But it really depends on the type of protein, because what these fish are actually digesting depends on, really just depends on what, depends on the amino acids, and that's the specific thing that these enzymes are designed for. So my camera battery died, and to be honest, I think I'll just use my laptop camera, even though it's not so great, but it's not really about watching me, I guess, so I just have to deal with what I've got. So anyway, amino acids are exclusive, and obviously that these fish are adapted to eat or digest particular ones. So there is a lot more to that protein than like the percentage so much. So a higher percentage might mean different things depending on those amino acids and those proteins actually present. Another thing brought up by this paper was particularly looking at fish meal. So Northobranchius, these killifish, they are insectivores, so they are mostly adapted to feeding on obviously insects. Just gonna try and sort out my camera. So that means that they aren't going to, well, this study either referenced or said, I read it a long time ago to be honest, so most of my memories of the paper are from them, but it did say that Northobranchius, they are insectivores, they actually struggle to digest or extract as much nutrients, and particularly phosphorus, from the bones or from fish meal, which makes you think that a lot of diets do contain fish meal, and these fishes probably aren't eating that much fish in the wild, so they're not actually adapted to extracting nutrients like calcium, phosphorus from fish so much. Maybe they're looking at particular other invertebrates. And does this mean that feeding bloodworm is a great idea, or particularly crickets, stuff like that? There's a wide diversity within invertebrates, and many of what we feed they probably won't see in the wild, so it makes it really difficult, and there is no perfect brand, no perfect diet. Some are better than others, and that's why I recommend looking at the ingredients and comparing to what these fish might eat in the wild if that's available. So there's many things that were brought up that I've always suspected, because we always know when we, with human diets, there's many links between diet and health conditions, longevity, stuff like that. So there is a known association of specific ingredients, resulting degenerative changes to the digestive tract, which is quoted in the paper, liver vacuolization, tumorigenesis, so that's cancers, and feeds promoting cancers is something that I've thought of, and I guess is somewhat known, but a paper actually mentioned it, and I think this is why we really need to think about what our fishes are feeding, and maybe pushing for better diets within the trade rather than the same diet being kicked out with just different names on it, because half of them are the same thing and you're paying maybe 2 times the price, 3 times the price, 4 times the price. And it's really important just to think about what you're feeding these animals, and frozen food isn't the answer. You do want a lot of those micro, macro, whatever nutrients, extra vitamins, proteins that you won't get from just feeding live food, just feeding frozen, and also from your own gel diet, because you won't, it's extremely expensive, a lot of the ingredients, and you won't be able to get as much variation as the fish would eat in the wild, and it's almost like feeding a very limited diet to a person. It would cause issues itself. And even when we look at dog feeds, we do know that there is an importance for that variety of vitamins and minerals that people that might feed raw and only very few things might struggle to get. So why not with fish? A lot of these diets, I think, are they're almost exactly the same as feeds meant for fish you eat, so aquaculture. And that's because when you're looking at aquaculture, you're looking for efficiency. And really, that efficiency is to get a big fish that's easy to sell as quick as possible for the least amount of money, because you want to shift that fish. The longer you have it, the more it's going to cost, and the more feed you need to, like, it's all more sort of short term. And with breeding stock, it's about producing as many babies, maybe in a short amount of time. You don't need that fish for its whole lifespan, because as its lifespan increases over time, eventually that number's going to go down of how much it's producing. And sometimes, so for trout, I know that I've seen it, maybe it was something, I think it's trout, where they, because there were females which had testes, once that, to get to those testes, you had to actually extract it from the fish, so euthanize the fish, which makes it very, it's not very viable to think about long term. So when we think about animals that are kept for food, it's very different from animals kept in our homes as pets. And also in pet stores as well. The only issue I'd say is that when a fish is imported from the wild, we really need to think about, just that these fish are adapted for that food, and as they're not being fed that food, will they lose the enzymes? Will other bacteria take over? And will this change whether the fish can actually be fed a healthy diet and live a healthy lifestyle? Because over time with a poor diet, they might never recover. And I've seen that with stunted fish particularly, where they never quite recover. They never quite put on as much weight as they should do. Or they never grow as well as they should do. And it is like, yes, like sometimes they can, but it's a bit of a risk or hit and miss situation. And diet is so important for these fish's lifestyles. Maybe this is the reason that fish don't live as long as they could in captivity, because it's just the importance of diet, and it's something that's so interesting, and there's papers on the topic. Some species less than others. So discus, we actually have quite a few. I've read maybe like 3, which for one species it for 3 species, plus a few undescribed species, it covers quite a variety. So we know that they're feeding largely on algae and detritus. They might pick on some invertebrates, but it's very little. And therefore we have a sort of an idea of what these fish eat in the wild, what they're adapted to. And then for some fish you have a lot less. Loricariidae, something you really have to apply the knowledge of, that look at their teeth, their morphology, and also maybe their relatives. But there are papers available, so I've done videos on the Hypencistrus, Pseudocanthicus, Leprocanthicus, Bariancistrus, and I'm going to do one on Chaetostoma because they're more than a diet for being an issue in captivity. And also, well, Ancistrus needs many videos, same for, I'd say, Hypostomus. But yeah, there's so much you can just look at a fish and tell its diet, like mouth position, whether it's got teeth, what sort of teeth, how many teeth, and body shape even. If you're going to be a predator, an ambush predator, or one that has to go at real speed, you're not going to be like a discus in shape. But it's such an interesting topic, and so many people are not looking into it. And recommend, unless you can really understand or look into how diet actually works, there's so many diets being recommended that really don't look into a fish's natural diet, or even dietary ecology, morphology, or anything like that, and treating fish as if they eat the same thing, which is like having, so a lot of those diets are feeding the same thing to most fishes. And imagine this, if you had a mammal, and you also had, so you had a rat, a bearded dragon, a snake, chickens, maybe a cockatiel, and also a few frogs, and you're feeding them exactly the same thing. Do you think that's a good idea? Because I don't think so, and that's what fish are being fed in captivity. And the same is generally for marine. And there's so many ways you can get creative. Like you can have those probably as a base diet maybe for some fishes. But you could also feed a wide diversity of different things. And there's where you can get really imaginative with what you can feed these fishes. Carnivores are the best for this. Herbivores, algivores less so, because so vegetables are not a natural diet for these fishes. Feeding them doesn't meet their nutritional needs. It compares nothing to algae, nothing to bryozoa, which are animals, but also any photosynthetic organism, bacteria. It doesn't compare. It's not offering enrichment. It's more, I use it to bulk up a fish. These fish, so Cichlids, Xanthus, Cichlids, Corydoras, they probably won't ever eat plants in the wild other than algae, bacteria, stuff like that, but also a few lesser known invertebrates, because when people say invertebrates they think, oh, insects. Firstly, bryozoa, hydra, all of these are animals. They're all eukaryotes. They're not simple at all, but they're so diverse, and you can see them in aquariums occasionally as well. But also bacterial colonies, fungi. Fungi are found in the guts of panaculars, and even they actually partition their niche, partition their diets. These fish are not feeding on the same thing as well. They might be an algivore, but they might partition slightly what they're eating. So a discus might live with another species that is a detritivore, an algivore, and they feed on slightly different things. Think like cattle and sheep, how they feed on different things. But they're feeding on the same area and the same sort of taxa in a way. So they might be feeding on the tops of the grass, might be feeding deep down roots, might be feeding other things, not just the grass. That's why it's always thinking about diversity and how can you cater for it, because diet is probably the main unknown within aquariums, or the main underrepresented. People aren't looking into it. There's nothing. It's one of the most interesting things as well. And as we're looking for fish that want to live long, live healthy lives, live natural lives, be a healthy body shape, healthy body weight, diet will change a lot of those things. And yes, it's not perfect at the moment. We've got somewhat, but they're general. So we've got brands like Brackish, they're really good. You've got brands like New Life Spectrum, they're really good. But that's about it. And they're still very general. So there's a lot more they could really specialise in. But at the moment, it's really difficult. And some ingredients are almost impossible in the wild, in captivity, to get, like sponges. But I think it's just something interesting. Why would never probably meet their wild diet? It would solve a lot of issues. So maybe there's quite a lot of fish that have very poor captive mortality, very difficult to keep in captivity, they don't live long, and half of it will be diet. And because we're not looking into diet, maybe that's why. Or maybe their fecundity is particularly bad, or the fry aren't making it. The adults aren't reaching breeding size. The adults aren't breeding at all. They aren't living towards that. There's so many fish that could really cater for. And even if we look at fish that have reasonable success, so discus, I find them really interesting. Their biology, their genetics, stuff like that. But maybe looking at why a lot of them have weird morphologies, why some, maybe there's an obesity problem with discus, which is no doubt they probably do have an obesity problem. And maybe they don't live that long, but there are reports of them living longer. And maybe because they're detritivores and algivores, that diet that they're being fed mostly is really affecting that liver. And liver is so important when when it comes to if you're eating the wrong thing. That's probably where it's being affected, and it's so difficult to see. If your fish dies, you don't see the liver, it doesn't pop out. You have to extract it, and the same with loricariids. But anyway, I'm going to end this now. I might do a live stream to discuss diet further and any questions on diets in fishes. I am only an evolutionary biologist. I look at morphology. I have never done isotopic analysis on them, but what I look at is really close to looking at the effects of diet in the wild and how diverse these fishes are and how can they be so diverse, and look at the result of it. So I might not be a dietitian, but I find it is so interesting, and I learn so much about what these fishes eat and how they partition it, because they might be more specialist than we think. They might be able to eat other things as well. So some fish, like a lot of Rift Valley cichlids, they specialise in one diet, but they can also feed on a wide variety of others if needed, or in times of difficulty, times of plenty. So it's something that is particularly interesting. But anyway, thank you for watching. I might do a live stream on the topic and more videos on the topic of diets and fishes, because it is really interesting. It's so unknown, there's so little on it, there's plenty of papers when it comes to fisheries and aquaculture, but does that apply? Because they are largely looking at different fish and looking for different reasons. And we're looking at maybe longevity and health, long-term health. So thank you for watching, and goodbye.